Welcome to everybody. Let's
welcome everybody.
Today's webinar. I will introduce you in a minute, Vincent. Let me just please before do a brief introduction. Today's webinar will be about scanning and particularly how scan is applied into the BIM process, and with some examples from our partner Bim-365. That will show their workflow in scan to BIM. We will let at the end space for the questions. The whole webinar should last around 30 to 40 minutes. Before we start, please note that you are muted, so you cannot interact using the microphone. This is because there are quite a few attendees, so it could be a mess. So if you have any questions or comments, please use the chat or the question area that you should see in your GoToWebinar menu on the right. I will leave some time at the end for answers, and maybe also in between if you have some question regarding the content that this is being shown. And of course, you can always write to me at flavio.vitiello@stonex.it later on in the following days for any other issue. So let's start. This is a kind of follow-up webinar to the one that we did during Digital Intergeo in October. For those of you who missed it and are interested, you can find it on our YouTube channel. So just go to YouTube and Google Stonex Positioning BIM in the YouTube search area, or use the link that is shown on the video. I will put it later on the chat. And you should be able to access the previous webinar, which lasted around 50 minutes. It was a general introduction about BIM. I will not, of course, repeat it. Just a few hints for those of you who are not very familiar with BIM, just as a very brief introduction to Vincent contents. So, as you might know, BIM is I would say, a methodology or a process to organize the use of information during a construction site. It's basically an information management technique or process or methodology, call it as you like, which covers the whole life cycle of the construction, from very early preliminary design to construction to maintenance, and it could be viewed as a cycle, a full life cycle process. It is being adopted worldwide. It first started mainly with government large contracts, large projects, but we see that it's more and more being adopted for small projects as well. It is mandatory in some areas or for some kind of project, and it will become more and more used. The European community here in Europe has put a very clear strategy of adopting it in the next term. At the core of the BIM methodology, there is a 3D model which collects as a repository all the attributes, all the information during time about the construction. This makes it very useful, the adoption of 3D data collecting tools like laser scanners. And we have seen in the previous webinar some examples how this can be used in BIM for as-built analysis, for class detection, for facility management and inventories, for designing and renovating overall building, to use the scan as a base to design new parts and new add-ons of the structure. So there are very different ways of using the 3D model. This is an example of how the scan is then modeled in an abstract 3D model, which collects all the attributes. Following up with this overview of the BIM of the previous webinar, we are very happy now today to host Vincent Hilaire, which is from Bim-365. Hello, Vincent.
Hello.
Bim-365 is a Stonex partner, is very active in France with BIM projects. So we asked them why not to share with other partners and users some examples of how you use the X300 and F6 in your projects, and how you use scanning technology in your workflow. So Vincent, today we will share a couple, maybe 2 or 3 examples from small projects to very large projects to see how they see the scan to BIM process. So I will leave now the presentation to Vincent. Let me unshare my video, and remember, I will make Vincent as now able to share his video. You should be able to do so, Vincent. Let's see.
Let me try that. Okay, perfect.
Okay, very good. So it's up to you, Vincent. As I said, any questions in the chat, please, and I will then put the questions to Vincent later.
Thanks, Flavio, for this very interesting introduction, and thanks everybody for connecting. Let me first share something on my screen. Flavio, can you confirm that people can see me?
Yes,
can see the screen? Okay, perfect, thanks. So I will not bore you to death with this kind of slides and such. I will just introduce very quickly what we are going to do and what we will see. First, we are a Bim-365. We love the X300, to be honest, and I would like to share with you some examples of things that we done with the Stonex X300. The first project is a modelization project. It's a simple one, but it showcases some of the very interesting facts about this project. The second one is a bit more complicated project, quite interesting. I will show an example of a modelization that we did, Flatness, how we use it to do MEP, and some stuff about Geo Positioning. All the examples and all these projects are actual projects that we did for paying customers. So it's actually live data, which is why it's not perfect. It's not wonderful. Some of them are a bit unfinished or not, there's some weird and glitches on the screen, but that's because it's actually live. Life is like that. Nothing is perfect. So my first project is about. I would like first to talk about the X300. We like the X300 as it is. Let me show that on the screen. Okay. The X300 is a very simple scanner that we use and we are actually selling. Some of the things that we like with the scanner, okay, I'm putting it down, it's a bit heavy. So we like the fact that it is a very robust scanner. That's something that is a big point for us. It's something that we can put into the hand of construction workers, no problem. It's weatherproof and it's easy to use. So that's something that we actually like, and we have used it a lot for that. Something that we do also, let me show that on the screen. Something that we like is that everything in the X300 is remotely controlled using Wi-Fi. So this is, you're connected to the scanners that I just showed. It means that there's no special equipment on site, and that's something that that makes things a bit easier for us. So as you can see, everything is easy to manage, and this will come into play into the next segment that we're going to have. So now, without further ado, let me talk about the next project. So the next project, this is a customer that works in plumbing, air conditioning, and construction. They want to do two things. First, they want to have a BIM model because they are going to transform their place and they're going to reshape the inside areas. Secondary for them, they are used to laser range methods, and they want to know what they can do with a system like that. Is that something that is useful for them? They are thinking about investing, but they are not too sure. So it's a way for them to test drive the technology. One of the interesting parameters is that everything had to be done in a single weekend only, and there's a lot of that place, so it was sometimes a bit difficult to scan. So let me first show, just a sec, I'm trying to find the correct thing. Here it is. So as you can see, that's a simple building. Let me move a bit around. It's a simple building that was all done in a single week, inside and outside. See, everything was scanned. One thing that is not obvious on the picture, and it was also a selling parameter for the X300 into that place, is that the system is weatherproof. And something that we do not see on the screen is that it was terrible weather. It was raining. We don't see it, but it was actually raining, and the temperature was around 4 to 6 degrees outside, which is not exactly a hot temperature. So it was nice to have something that we can just leave outside. We could just scan, and this thing was working even in terrible weather with a lot of cold. This enabled us to get the full model of the place, as you can see, outside and inside. I'm just going to demonstrate the outside. So that's a fairly large building. This is a fairly large building with a lot of details and a lot of clutter, as you can see here, that we obviously had to remove before modeling. So this took about half a day to scan the outside, including a safety visit and making sure that we have everything that we needed. Now, for the scans, it was actually very simple because there was only 9 scans to do for the outside. Let me demonstrate that. Okay, and disregard this thing on the side. It's just something a bit complicated we did for them. So if we look here, we can see the scans. As the X300, has a large scanning range. That was very simple for us to not do a lot of scans and have the full area very easily. On the back, you can see there is 3 scans only. And the front, we put a bit more scans. Well, mainly because we wanted to have a very accurate rendering, but as you can see, most of it is actually 1 scan here and 3 scans here. You can see it by the colors. So it was quick, and that was something that was interesting for the customer to see. It was simple to use. So regarding now the organization of this system, as everything was to be done very quickly and we didn't have a lot of time, One thing that was a huge convenience for us was to be able to use the X300 using the Wi-Fi control. So the way we were working, my business associate was on site, and I was working from home. And you just scan stuff. He was scanning stuff using his phone to control it. And when there was 2 or 3 scans done, he just downloads the scan like that, like I'm just doing right now. Got them on the phone and just send them to me by 4G. So even if I was not in the location, he was in another country, I was able to get things quickly, process them, and make sure that we had everything ready and working. That was a good system for us, and he didn't have to think too much, and I was able to make sure that we had everything correctly and there was no surprises in there after that. So that was something that we really liked. So now, one of the questions that we had regarding this project from the customer is they thought that registration, making sure that all the scans are aligned correctly could be something difficult for them. They wanted to make sure that it was not going to be a difficult system. So this is actually live unprocessed data from the scanner. As you can see, well, this is obviously not exactly like the house should be, because everything is centered onto the scanner origin, which has moved from one scan to another one. So we can see that, well, things have not been registered. We still have 3 scans, but they are not registered. So one of the questions was, is that something that is going to be difficult for us? And is that something that we will be able to do, because we are not technicians of that, we are not specialists of that, so how can we do? One thing that was interesting regarding Stonex Reconstructor and the system was the ability to do the automatic registration. So as you can see, this is not correctly registered. So I'm going to take those live data, and it's actual data. I have not done anything. It's actual data from the scanner, and I'm just trying to find, okay. I'm going to just use the automatic registration. This is live computation on a very simple computer. It's not a very powerful one. Okay, that is done. Let's check. Let's hope I don't have a demo effect. Yeah, it's working perfectly. So my computer is a bit slow. So as you can see, this was okay. As you can see, alignment was done correctly, and now instead of having a disjointed point clouds, they have been registered correctly, automatically, and it's a huge time saver for us. So that's something that we demonstrated to the customer, customer and prospect, because he was interested into acquiring this thing. And well, that was a good system. Now we have a correct thing. We have the actual house, the backside of the house, that has been automatically registered. Okay. So so it's easy, it's simple, and there's nothing much to do. It's possible when we have a point cloud to export it. I'm not going to do it live because the process is a bit slow on this computer. However, we can see the result. Let me show the result in Revit. This is the final results that we had for this customer regarding the facade. Everything was modeled according to what the customer wanted. The outside is not extremely complicated. As you can see, it's basic. It's quite basic actually. There's not much. However, the inside, and that's where it was more interesting for them, is also modeled correctly. Let me show that. Okay, I'm going to show the level 0. And we can see some interesting facts. As you can see, there's a few rooms. This is not complicated, but one of the difficulties that the walls are not straight. This is because it's an old building, and actually not a lot of things are parallel here. This is a bit slanted. This is a bit slanted, and it's like that absolutely everywhere. none of the bin dimensions are the same, and there's a lot of weird things. So that was one of the difficulties in that project. With the Stonex, it was easy to take a lot of scans and make sure they were correct, even if the place was very clustered. Let me show you on the screen. Oh, sorry. Let me show you on the screen. I'm going to unload all of that. So just a sec, here it is. I'm removing that. I'm putting it myself here. So that's actual live data, not live, but it's actual data from this place. As you can see, it's filled up with things. We have a lot of details, really a huge range. So that was also a problem for us. We didn't, not a problem, but it was also a problem for that. They didn't know how to model that using just a simple telemeters and such. Using the X300, we were able to get a good scan even of those parts very far away, and even on the other side, everywhere, using automatic registration, which enabled us to have a correct modelization even on the higher levels, which were the ones that they were really keen on seeing. Now we can see the higher level here. If it displays, yeah, okay, this is this one. Just a sec, here it is, and voila. So here we have the storage area that we just have seen before. And one thing that was very pleasant using the X300 is that we can display the point clouds exported from the X300 into Recap on the same model, so we can check that we have the correct modeling and that everything is modeled accurately. You can see that the scan shows that as an example here that this wall is slanted. We actually see a slanted wall, so it's very easy to check for the customer. It's very easy to check also for us. That enables us to have a full modelization of all levels, including basement. This is an example of what we have for the ground level. You can see the doors here as an example. And we have everything, including the point cloud. If you see upstairs, same thing. And we have the storage area here that we can see. We have the walls, we have everything. That was an interesting project for us. If I want to check if I want to sum up what the benefits were for us and for the customer, we were able to do that on time, 2 days only. There are 68 scans, which is not much for a basement, a ground floor, 2 stories, and all of the outside, and a bit of training of the customer. 2 weeks of modeling, mainly due to this place having extremely weird walls that were not straight and sometimes even vertically inclined. And we were able to provide a Revit beam model. And some interesting points that make this thing a bit different from the competition. We can scan in awful weather. It was clearly demonstrated to the customer. We didn't plan for the weather, but he was able to see that we are able to work even if it's difficult outside, and they have to work in difficult weather sometimes. Walls not straight are not a problem, and we can work in a place with a lot of clutter. So all of that were interesting points. 2 points that that I didn't put there, but I should have. The customer was interested by the ability of the X300 to be operated from a phone using Wi-Fi, and that it's extremely simple to use. So it doesn't have to train his working people, actual people going to do plumbing and such. They can still do it easily, and this thing is sturdy, so they are not going to destroy it. The customer was satisfied. he was able to start his redevelopment project, and well, he's actually interested in buying a X300, though money is a bit tight at the moment, so this thing is a bit on hold. But I think we have good chances of getting an order. We have provided a quote for that already. So that was the first project. Okay, any questions?
Yes, sorry to interrupt you, Vincent. This was a nice example, very simple, but yet it has many of the practical things that you encounter when you do scanning. One of the questions that less experienced users always put is, how do you align or register inside with outside? Did you find any problem in doing that? Did you do it, or can you?
Okay, that's not part of the demo, but I can show you some of the inside if you want. You will have an idea. Yeah, we did have a few issues with that, not because of the Stonex. The Stonex was actually really nice and worked correctly. The problem was mainly there was so much of clutter that sometimes there was some blind spots. That was the main issue we had. There was so much of clutter that it was a bit difficult to make sure that we had everything.
Yeah, no, sorry. What I meant is how do you put together the inside scan with the outside?
So yeah. From inside to outside, that is an interesting question. On this one and on a lot of projects we've done before, what we do usually, we try to use a feature that is common from the inside and outside. This is not a good place where I can demonstrate it here. However, let me get back to the building itself. When we did just a sec. When we did the scans, okay, I'm just removing myself and making myself a bit further away. There are some features that are common from the outside area and the inside areas that we can use regarding positioning of the levels relatively one to another. We can use the doors when we are inside, and this is why everything is open. When we are inside, we can see outside, and that's a good way for us to get some accurate positioning. Where inside, we can also get some view of the inside, and that's the way we did it. Let me show you. If I'm just going to show one scan. So it's a laser scanning, so we have some view of the inside when we are outside. The same is true regarding the inside. We can see the door, and we can see some features like, for example, those bottles that were those bottles and this thing. We put them near. We put some of them actually near from the entrance to be able to easily have the same common things outside and inside. So that's one way to do it. The other way, because obviously this works only for doors, and we don't have doors everywhere, we can use also the windows. The windows are a good way for us to be able to align things correctly. So that's another way we did it. And lastly, some things that we were able to do here, as you can see from the outside, we can see the roof, and that's the same roof from inside. So it was possible to do alignment of these two, the point clouds from inside and outside correctly. We know that there could be a small geometric discrepancy. It can be up to 2 or 3 millimeters, rarely more than that. On this one, if we look at the wall thickness, it really matches with what we saw on site. Everything seems to align, so I think we are actually very, very good, more than we usually plan for. But I always tell that is not going to be completely perfect. You have to plan when you do the scan to have the inside and the outside in some of the pictures so we can do the alignment. The same thing is true regarding levels together. We try to have some common features like a staircase or something like that, or a place when we can see both things together so that we have everything on the same picture. So let me just show you on the inside something that could be a good example. That is not very interesting, this one. Okay, I don't remember exactly how this thing is laid out, so it could be, okay. So as an example here, we can see outside from inside. and that's one of the way we did the alignment. We're able to get some common features like the door, some parts of the car, the building that is on the back, and such. It's simple enough, and in our experience, it gives good results usually. And we have also from the outside, we can see some of the walls that are inside. I don't know if that's, I have no idea if that answers your question correctly.
Yes, very good.
Okay.
In some occasions where you have less communication between inside outside, small windows, small doors, it is also useful to use a total station to build a topographic base.
That is correct, yeah.
But yeah, that's a
so that's another option. On this customer, we wanted also to, well, they tend to do mainly to work mainly inside, so we didn't care much for that. The total station can be a good system. But as I say, if it works, it works. So just use something that works for you. Most of the time, just using a laser scanner for us was enough. So it's not difficult to open a window and to get some communication from inside to inside, or to open a door or something like that. So it's simple enough that it works. And it's something that one of the benefits that we could demonstrate to that prospect is that this is simple to do. His workers can do it. He doesn't have to train anybody. Like for a total station, he can just, the guy on site can just put this thing. It's sturdy enough. It's not difficult. It will not destroy anything, and you don't have to train somebody. So it was a selling point for that in this specific case. So any other question?
No, maybe you can share the other examples. Maybe at the end we can sum up.
Sure. Okay. So I'm just trying to share my screen. So we talk about what we do. So I'm the technical manager for Bim-365, and I have a co-founder that is Gregory Monet, which is more the sales manager. We have two companies. We have two activities where we use the Stonex. We use the Stonex products. Scan is more dedicated to scan and modeling, and Bim we do sales also. Sometimes we discovered first that people sometimes just want to do to have scans and modeling and don't want to buy the product. So we do both. We are dedicated to training and to scanning and do support. We don't do anything else. We are doing quite a lot of business with Stonex, but we can also use other products if it works for us. So we like to advise our customer. Our goal is not to make a lot of money, but to have very satisfied customer. We want to stay a small organization. And so the second project is a larger project. It's 4 stories, each about 2,000 meters square, and there is a basement also. There's a lot of pipes, as you can imagine. An hospital will have many pipes and tubes and electricity and ducts for air conditioning and such. They have plans, but they are from the 80s, so they are not up to date. And they want to do a major renovation, including the removal of an air processing room. So before removing the air processing room, they need to know which duct is going where, which pipe is going to which place, and they don't have a very good plan of that. So they want a BIM model with the architecture, like we showcased in the previous thing. So architecture is something that we can do easily. And also with MEP, which is all the technical stuff, having a modelization, having a model, including pipes and ducts and such for air, okay? So in addition to that, there's a few constraints. It was just during SARS-CoV-2 outbreak. So SARS-CoV-2 is a COVID, so it was a bit difficult to plan for anything because borders were closed and they were open again. Then there was some specific restrictions regarding working into the hospitals and such. There was still processing people and patients, so that's another constraint, and I will explain that just after that. There was some time constraints. The project was a bit rushed, and while everything was to be done very quickly. There's Geo Positioning and hazardous locations. Some of the locations are really high, or you have a lot of pipes everywhere, so it's difficult to move without banging yourself everywhere. There's some dangerous fluids going around, so not everything can be done without thinking. We have to be careful and we have to think about what we are doing. So, without further ado, let me move on to the second one. So let me show you this. I'm going to shut down that and that because becoming a bit of clutter on this thing. So on this picture, we can see that we were able to use a scanner. This is actual data again from the scanner. It's actually a single scan that we did on site. As you can see, we still have people in the hospital. We're able to work with patients around, and some patients in really bad condition, going to surgery or radiotherapy or such, without disturbing too much the activity of the place and without exposing ourselves to too much risk. As the scanner is waterproof and is something that is easy to clean, you can just wipe it out. There's no moving part outside, so that's very nice. We were able to explain to the hospital people that we could actually work around COVID people without danger, at least regarding this scanner, and that we were not going to disturb them by moving around a bit, not moving around too much. Once the scanner was in place, we were able to scan. This is one single scan. You can see the range is quite good. That was something that helped us a lot. Another thing that was nice, just a sec. As you can see, even in large corridors like that, we can still scan. And if you're wondering, Vincent, what are those things here? It's people moving across the scanner. People who are moving all the time. Well, this guy was probably not too fast, but during the scan itself, there was many people, and it was very busy. Actually, it was a bit frightening because there was always something happening, and we were really wondering if you were safe enough. And there was no inoculation at this time. It was 1 year ago. So easy to scan, non-intrusive, easy to clean. Those were selling points for the project. We're able to demonstrate that we could work without any issue. Also, the result that we got from this location, as an example, right, that's not the correct one. We're able, that's for just one of the level. We're able to get this, which is, just a second, that is, we were just there. When we are doing the two first scan, we are at this location and this location. This place is actually one of the most difficult places we had to scan in that building and in most of the projects because everything is in a straight line, as you can see. So any kind there is any kind of deviation or any kind of registration error, everything will not match, and at the end, the corridors or the floor will not match together. That's actually not simple, and it was a bit difficult for us to process that correctly. We did some additional scanning after that to make sure that everything was fine. On this one, we have 69 scans, if I remember correctly. I don't have the figure at hand, but I think it's 69 scans, which allows us to have a full view of all the corridors. We didn't go into the operating theaters and the radio rooms or the offices because first there were people, and secondly, it's a node ceiling, so we can even if we scan, we cannot see the pipes and such, so it's not very useful for them. Using the data from the X300 and the registration on this floor, as an example, we were able to, and that's the first floor we did, we were able to move to, let me check. Okay, that's not what I wanted, but that's okay. I'm just going to display it on the screen. We're able to do that. This is a full view of the level. You can see the same shape with everything, including pillars, correctly positioned and correctly positioned, all the doors, partitions, and everything. We add paper plans, and actually they don't match. The paper plans from the 80s don't match. We still, obviously, the pillars are about at the same location, but some of them were removed, and we found one additional pillar, which was surprising for us. The partition has moved a lot, so that was not matching with the plans any longer. So that was provided to the architects, so they could have that, and they could have a correct plan of that floor. We did the same thing for the other floors. As an example, we have another floor here. Okay, this thing is a bit slow, and that's not. That is not what I wanted now. Just a second. Voilà. That's another floor. As an example, this floor is a bit more complicated and involved because I showed also some of the top floor. That's not okay. That's not interesting. Let's move on to this floor. As an example, this is a basement with the X300 using scanning data from the system. We're able to reconstruct all of the basement, and after that, which I will show in the second part, we were able to position the pipes and such. We can really see easily all of the structural beams here and also of the walls that are outside. This is something that is also coming from live data from the scanner. We can show that here. Let me show you. So on the scanner registration data, we were able to get with the register scan, we were able to get all the beams, location of the supporting beams here, the ceilings, windows. There are some windows going outside for making sure there's some air going into this place, and we can okay, finish that please. We can also see the floor, which is a bit uneven. That's a bit surprising. Okay. Okay. We can see the floor. We can see some of the beams, and we can see some of the what do you call that? Some of the pipes and such. See, we have a pipe here going from one place to another and such. So that's one part. We were able to do. We were able to do accurately architectural data from the inside. We were able to process the outside also. Let me show that. It's not this one, and it's not the one I wanted to. This one. So as the range is good, with only 3 scans, we're able to get all of the facade data, for example, in this place, which is quite large. I don't know if you can see, but it's a very, very large place. All of that is 3 scans only. And this is actual data from the scanner. The colors are a bit weird because well, the sun has changed location and there was some clouds, so this place is not lit as the same in one scan and the other it's region-wide. But everything else is good, and we can see the various clouds and such very easily, quickly. So ability to easily get data from, we were able to work easily with the constraints that we had regarding safety and not contaminating patient, and ability to disinfect things if needed. We were able also to get the how do you call that, to do maps and to do plans and to provide them into Autodesk or into Revit, and to also do the outside part and inside courtyards and such easily. Flavio, will there be any question on this first part of that project before we move to the next one?
Well, there is one friend that has, I guess, connection problems because he cannot hear the voice well, but it's only one. So I guess it's connection because I can hear you very well. Anyway, the whole webinar will be then published on our social channels, so don't worry, you will be able to listen. But there are some questions. One is one friend is asking, which is the interval of every station in your scan, I guess, is the interval between the scanning position.
Yes, that is a very interesting question. Yeah, but it's a very interesting question. It really depends. Sorry, that's probably not the answer you're looking for. It's not like there is one system that will work for everything in this project. So if I gave an example of the courtyard, the external courtyard with the surgery place. Okay, let's just me show something on the screen. Just give me 1 minute. So I'm going to display my screen. So this you can see an example of the location of the scan. We on this one, we did one location in about every room or corridors. These little things there. Actually, I can show what it looks like because that could be more easy to see if I explain. Okay, just a sec. Yeah, that is not bad. So we have little things like that. Okay, that's an example. You can see one of the place. On this one, as an example, we will typically do 2 scans, one on each side of this little pocket. I don't know what's the correct term for that. Is a wait. It was a waiting room actually. So we did probably 2 scans or one, or we did actually only one. So we did 1 scan in this little pocket, and then we will have scans in the corridor so that we can see both of these waiting rooms and corridor, and we spaced it according to the number of waiting rooms and nooks and crannies we had. So it's not like it's a fixed regular interval. It was depending on the specifics of the place. In this part, as an example, we can see there's quite a bit of scans because first there was a lot of clutter. So sometimes we just had to scan and we knew that there was something in the way or there was a patient there. So we just did a scan and then another one after. It's not a fixed location. We did the scan so that it was matching the waiting rooms and also matching the geometric dimension of the corridors. So about one in every, I would say about one in every 15 meters, 20 meters, and then in each of these little waiting rooms or in the not operating theater, but the technical places we have to do a scan at. For this one, if we look now in the, I'm not saying it, if we look here, we can see that 3 scans and it's over. So we are making sure that we had everything. Actually, I think just 1 scan would have been enough, but we wanted to be sure not to have to come again. It was a bit far away, so for us it was easier not to come back. I'm just trying to. No, I don't have it open here. If I take now the level 91, the basement, I have not prepared a view with all of the scans. We did a scan. Well, it was a bit depending what we had on site. Some of these places are, as an example, have huge machinery here. So we did what we could. Sometimes we did scans around the machinery, but usually, given the scan of the range of the scanner, we know that one in every 20 or 30 meters is really good enough, and we put them in a checker pattern so that there's a good overlap between things. I'm not sure that helps a lot regarding the question.
Okay.
And I've closed. Okay.
Another question is what is the accuracy level?
Well, that's the accuracy level is in the data sheet, and I don't remember it exactly. We know that for this kind of for the type of scans we do, we can expect an accuracy of about 2 to 3 millimeters. That's what we usually see. So there will be some, and it depends of the range that we are doing. If we are doing extremely long scans, obviously at the very, very far end of the range, the accuracy will be a bit less. As an example, here it's not going to be 1 millimeter exactly here. It's going to be a bit more. If we have something that is here, it's going to be 2 or 3 millimeters. According to the data sheet, from our observation, we usually almost always fit into 1 or 2 millimeter, depending on the type of surface. Obviously, if the wall is very flat, it's better to get a good accuracy reading and a good reflection. Then if we have, sometimes we do have a carpet on walls, so then well, it's not as good as it. Or if the wall has some structure, as an example, sometimes you have some kind of concrete on the wall, then there will be some little discrepancies between measurements, usually around 1 to 3 millimeters from my data. That's what I plan for usually. And actually, Flavio, if you have a better data, perhaps you can answer.
Well, it depends very much, as you said, on the distance, on the angle at which the laser beam reaches the material, and so on. But yeah.
Yeah. Okay. So that's it. Any other question?
No, not for the moment. Maybe you can go on.
Okay.
We are now some 50 minutes into the webinar. So
okay. So I'm going to show another one. Oh, yeah. Okay. I'm going to show now another interesting thing that we did. As you can see, this is the roof. That's the rooftop. The rooftop is of that place. That's where the air conditioning room is. This rooftop is going to be is the one that was going to be removed. If we look at the picture, we have the impression that this is a flat surface here, and at the back you have a flat surface. And this is obviously grass, so it's not flat. We can that's easy to understand, but actually, one of the requirements was to be able to do a flatness survey of that because it's not flat. And that's a bit weird because it doesn't show, but it's really not flat at all. So using the X300 and fine measurements, we were able to get an accurate reading of the altitude of the surfaces with. Okay, I'm just trying to click on this thing. Display stupid thing. Okay, so using that, we were able to get an accurate reading of those surfaces. And as you can see, this is not flat at all. The difference between the purple area here and the yellow area here is about 12 centimeters. So it doesn't show when you're on site because it's a very large place, but it's actually not flat. This was requested so that the architect could have a modeling of the surface and do something and plan for the next. I'm trying to find the word for putting some cranes and things like that. So using the altitude and the readings that we had. Okay, I cannot move. Voilà. Using altitude and the data that we measured, we were able to get an accurate altitude of everything, and then do a modelization using. It's not the correct one. Sorry. We were able to do an accurate wireframe. So this wireframe does matches with the altitude, as you can see, and this was exported then to Revit. Into Revit, if I'm going to Revit, and I'm not seeing it. Okay. So into Revit, we imported the wireframe using a script, and we were able to model exactly the same thing into the BIM model. I'm just displaying on screen. That was an interesting point for that customer. Because the flatness was not something they knew how to do, and they wanted to have something that was simple without too much, without using total station and such, something that was easy to do in not a lot of time. Okay, it seems that my Revit is stuck. I will perhaps restart it. Okay, that's so now we can see that we have been able to import that into the Revit model, and you can see the little triangles everywhere. So this is a bit slow to render because there's a lot of little elements, little triangles, and so Revit is well, it doesn't like that too much. So, but that's this way they had a correct model that they could use. We did the same thing for the grass with less, how can I say, with less accuracy because it's grass, so But it's not like it's extreme. It matters a lot. And same thing for that little path here that goes to a door, so that they could use it in the future also to put some of the foot of cranes and things like that. So the flatness is an interesting thing that we can do with the X300. It works actually quite well, and it's simple to do. The process was quite easy actually, and simple to do. So any question regarding this part?
Yes, we have a couple more questions. One question is about the registration, I guess. Is there any loss of accuracy when merging the scans?
Well, there will not be no. The goal is to have an accurate reading. We know that that point clouds are not going to match exactly. There's always a very slight discrepancy. If I'm taking the example of the house that we had just before, the typical medium error between two point clouds is less than 2 millimeters, which is really good. So there's not. It's not much of an issue. Practically, it's not much of an issue. We did not notice that. It's within the accuracy of the scanner.
Yeah, and if I may add, it also depends on the grid interval that you choose when you do the scanning, and also
yeah, sure.
there are techniques like using targets, using again, topographic references, etc. There are techniques if you need a really good match, but normally, yes, what Vincent said is the normal result that you could expect to get. Then there is another question: how big is the output point cloud data? Will it be too big for Revit?
We don't use the data directly like that. We don't just output something from, we don't just take the point clouds, merge them together and put them into Revit. First, because it's not really useful. Secondly, because as you said, the data can be a bit too large. So let me show something. This is going to be very easy to show. Just a sec. I just need to find the correct grid. Okay, if I take this one as an example, first we didn't do a modeling of and did a very for this one as an example, this wireframe, we were a bit careful not to have too large a grid. But I understand the question is more for point clouds. If we take this one, some things that we do when we do things like that, or we can do we can take this one, the full level here. You see, it says density. Because what we do is we take the various point clouds and we want to have a maximum density of 1 point every centimeter. So if I'm going to go near from a wall as an example, you can see there is sorry, I moved. So there's not too many points. We have about 1 point in each millimeter, which is good. This place was scanned, I don't know, many times. We have probably, on this wall, we have probably 10 scans because it was scanned from here, it was scanned from this one, from another place, from outside, from off the top of the roof and such. So we have this system so that the resulting file is not too large and we still have a good reading. We use a density merging, 1 point every X centimeter. If I'm looking at this point cloud, which encompasses everything on the rooftop, so it's quite a large one actually. Let's have a look. So this one is only 6 GB, and we have 152 million points, which seems like a lot, but it's not that much. Actually, it's perfectly okay. The 6 GB is including a color data that is going to be transferred to Revit, but we have also altitude and we have a few other processing that is not going to be transferred into Revit, so it's not much of an issue. This is actually something that we can easily export into Revit. Oh, and we can also be a bit clever. As an example, if I'm working on a level and I want to model it, I can just export that level. That's what we do usually. We don't export everything. We will have one recap file by level because it just makes things a bit easier to work with. Any other is the question satisfactory? The answer satisfactory?
Yeah, of course. Okay, no more questions for the moment.
Okay, last one. So this one, I said that we wanted to have a modeling of pipes and such. So let me just find my let me try to find the air conditioning room. So that's an air conditioning room scan. I'm just putting 2-point clouds. We don't need to have all of them. It's going to be a bit boring. As you can see, this room is filled with machinery. We have pipes here, big pipes, little pipes, supporting columns. We can have things laying on the ground also, so it's not easy. One of the question is how to redo the how do you call that, the schematics. So this is the schematic that they had. And that's the best one we could find. It's actually not too bad, but that's the schematic they had. We know, we checked, and it doesn't match with reality. There was some changes. Well, obviously in 20 years there are going to be some changes. So some of the stuff is still valid, like machine name and such, and the ducts and pipes have moved. Also, they don't have a plan of all the little pipes and things. So question was how to use a scanner to move from this to modeling of the pipes and everything. So what we did some scans inside of the places to be able to get the correct, accurate location of the big machinery here and the main ducts. This was used to be able to know where ducts and machinery were, where they are located, and also to be able to have relative positions of things. Using that, it's not enough. It's not something that is enough for us, so we need a bit more things. What we did in addition to that, let's try to show that. We took many pictures with a referencement system, so we could have an idea of which pipe was going there, and to know the pipes names and to be able to read everything. So I'm putting the big pipes on the screen, but we have also a little water pipes and things like that everywhere. So we did those kind of pictures so that we could see everything and we could have a good reading on the names of that, and also the color codes like this one to be able to identify the content. That's just some example. We have thousands of pictures of the buildings and inside and out. Using the pictures and movies, we did movies, and so using pictures, movies, and the scanner, we were able to rebuild a model. I'm just going to show it. This is a model as an example. Let me find the entrance. It's there. So this is a model of on which we can see the architectural walls here and the beams and such. And we have the pipes, the ducts, and we have the pipes and ducts. So as an example, we can see that this machine here is a machine IG16 something, on which we will have a pipe going out of it and going to this one, and then going into the floor here, because I remember a bit of the place. You saw it going into the floor, and I'm showing it from behind, okay, from below. We have also the ducts with boiling water, hot water, cold water, and also recycled water and such. Modeled correctly. It doesn't have to be accurate to the millimeters. The accuracy of that is about for the big pipes like that, it's about 1 centimeter. The little pipes, it's about 5 millimeters. About we all know it doesn't matter. However, what mattered was to have the correct location of pipes going in the levels below, so we could reconnect them to the levels that were obviously below. Same thing regarding if we take only the little ducts. See, these are the pipes, little pipes with water and such. You can see that we have the full circuits with all the elements and also the big machinery that we saw on the floor. If we look here, that's the entrance. That's what we saw in the scan just before. So the scanner was able to get us the location of this machinery and the big pipes. The little one, it was modeled mainly using pictures, because the scanner cannot go above things and cannot see behind another pipe and these kind of things. Using all of that, we were able to model this place. We were able to do it also for the other levels, using exactly the same technique. taking pictures and using the scanner to get relative position. As an example, if I'm taking the level 91, which is one of the levels they have, we have also a reading of all the rooms, and well, it's obviously a bit complicated because it's an hospital, so you have a lot of pipes with various fluids. I don't remember all of them. It was a bit complicated. It's a lot and lots of fluid and things, and going to the walls and intake and outtake and such. So this was done by going above the ceilings, the suspended ceilings, so we could get a reading of what was inside. So if I take an example, we were just moving the suspending ceilings, taking pictures and using it to identify the pipes and ducts and such. It was a very time-consuming process, but this way we were able to operate even if there were patients and even if they were still doing things into the hospital. So after that, we put everything back together and we spent some time modeling things. So using that, we're able to get a modeling of the technical pipes and machinery inside of the buildings. If I look at the result, just a second. This thing is never working when I want it to. Oh, just a sec. I'm going to move to this one. So conclusion. We did about, because I don't remember exactly how much, but it was slightly more than 390 scans with more than 10,000 pictures. We went there 5 times, and each time we stayed for about a week, a bit more, a bit less, depending on the time. There was 4 weeks of modeling total. The modeling, architectural modeling was not very complicated. However, the modeling of MEP is extremely long and time consuming, so that took a bit of time. An interesting point in that project, first, the health and safety issue, working in a high location where you cannot, you have to be careful, working in places where things have to be clean and have to be cleaned after working. Where it is important to be non-intrusive, okay, to not annoy people by putting markers and such or putting things on the wall. We didn't use any target. Everything was always staying clean. The X300 was very adapted to this kind of large area, and it can be used as an assistance to do MEP. Cannot do MEP by itself because it's just too complicated, and you have pipes going behind other pipes and such, so we cannot see through that. We have to take pictures and go on site. We are able also to do a geo positioning. That's something that I have not shown too much, but we used a GPS unit from Stonex as an example on the rooftop. This is my business partner. We are just scanning stuff as an example. And we're using a S800, I think. I don't remember the model, to be able to get location of some specific points that we used as references after that. So we're able to put a good geo positioning. That was very easy to do with Reconstructor. It works extremely well for that. So any Flavio, I think this is it for me regarding this part of the project. Flavio, will there be any questions?
No, just comment on my side. I've seen in similar projects that F6 or handheld scanner works pretty well for small pipes. So maybe an idea could be to use on top or instead of the pictures also small scans made with details of the piping, less accessible piping with F6.
Yeah, that's a good point. We tried, actually we tried it. It was just not convenient because of the size of the place. It's so large that it's just not possible to do it like that. We have to imagine that it's 4 floors, and each of them are 2,100 meters with pipes everywhere in suspended ceilings or just lying on the ground. So we need something that could scale easily to be able to fit into the. We did, however, use the F6 on another project. It's an extremely good scanner. I actually like it a lot. It's just that it was not possible with this thing, unfortunately.
Okay. So I think this was rather interesting. At least it was to me. I hope also for all the attendees, I'm sure. Thank you very much, Vincent. Let's keep in contact.
Thanks.
And
thank you, Flavio.
Thanks everybody.
Thanks everybody.
Everybody in presence very soon because it's much better
after COVID.
Okay. Thank you. I will close the webinar now. Bye-bye.